Okay, so here's the circuit I designed in dip trace for the 8-channel sprinkler system controller. It'll do 8 zones. I'm not going to get into too much detail of how I laid it out, but from this software I then export the Gerber file that has all the traces, and then also the NC drill report or the Exelon file for all the drills. Once I export those two files in Gerber format, then I use another piece of software called FlatCam, and that converts all the Gerber and the NC drill report files into G code. But also, I get to tell it what my different mill sizes are. So I use a 30-degree 0.1 millimeter V-bit to route out all the traces. Then I use an 8/10 millimeter actual drill to drill the holes. So you have to take the first Gerber file and then create the geometry for the isolation routing, and then convert that to G code that my milling machine can understand. So you make 2 G code files with this software. So you have the G code file for the routing, and then the G code file for all the individual drills, because this is a through hole design. And that's about it. And then since I do this on another machine, I just plop the 2 finished files onto a USB stick and I ran over to the other machine that operates my mill. So that's it for now. I'll come back and show you the milled out board, and then after that I'll show you how I just paint the clad and then etch away the solder points, and then I'll get it all assembled and we'll go from there. So over and out for now. So I just got done milling out this board. It's an 8-zone sprinkler control board that's going to be Alexa compatible too. It'll have its own Android app and iOS app, but if you happen to have Alexa, I'm going to make it Alexa compatible. Then all you have to say is Alexa discover devices, and then she'll tell you what devices, and then she'll pick this one up, and then it'll tell Alexa what commands it accepts, and so she'll catalog that. And then you can be like, Alexa, turn on zone 1 of the sprinkler for 15 minutes, and she'll know what to do. So I just got done routing out the board with the 30-degree 1/10 millimeter V-bit. Then I ran the drill batch and then drilled all the holes. So now I'm going to take the board out. I'm going to clean it up. I'm going to paint the clad and then etch away the parts that need to be soldered, and then I'll be back and you'll see it's going to come out fairly nice. For a prototype board, it's going to be great. So I just got done painting the copper clad and the fiberglass side, because this is a single-sided board. So now, as you can see there, the whole thing's painted. So in the areas where you need to solder, I'm going to scrape away the paint so it can take solder, but yet the whole rest of the board is full solder mask to keep the copper protected, from elements, so it doesn't get all green like your pennies will get all green with moisture and humidity. So, and it makes it look way cool. Makes it look all professional. So as soon as this paint dries real nice, I'm going to go ahead and scrape back everywhere it needs to take solder, and then it's going to look pretty cool, because my Wemos module is going to go in the middle, see, and the blue matches, so it's going to look sweet. my little screw down wire connectors, terminal blocks. They're going to look cool on there too because they're blue, so it's all going to match. So that's it for now. Over and out. Okay, so now I etched away all the pads, the vias, so that you can solder to them. So now I have my homemade full solder mask board. How badass is that? I would say it's pretty badass, if I do say so myself. So now it's ready for solder, ready for parts. There's the other side. I just painted it so it's all cool looking. So once I put the parts through and solder everything, it'll look pretty much like a pro board. Okay, well, here's pretty much the finished product, with the exception of, if you see these 4 SCRs here, there's 4 more spots, but I'm out of stock of those. I'll have to get them in. Each one of these turns on a solenoid for each one of your sprinkler zones. So right now this board is capable of doing 4 zones, but once I get more of these in, I'll put the other 4 in, and it'll be a complete 8-zone lawn sprinkler controller board that I've got to write an Android app for it and an iOS compatible one. Well, the app will be both iOS and Android compatible, and you'll also be able to access it through any browser, and it'll also be Alexa compatible here eventually. I have to make revisions for an FM receiver module which the Alexa uses in order to set it up. So at this point, you know, it should be a working board. I haven't tested it yet, but it's looking the part. These are all the terminal blocks for all the zones. 2 wires each zone, so 8 zones, and then this is just your 24-volt AC power supply that energizes these coils. Here's a rectifier bridge here, and a 5-volt regulator and some filtering so that the ESP8266 Wemos module gets its 5 volts, and then USB to flash it. But that's pretty much how you make a Homebrew pro quality at home circuit board with solder mask. So how fucking cool is that, right? You're gonna learn a lot from the Kixie man. So that's how you design a circuit board, etch it out, drill it, paint it, scratch away the clad, place the components and everything, all homebrew, like a boss.